So as in the last video, we talked about linear functions and linear relationships. Today, we're going to be talking about the second step, which is quadratics. So, in these videos, we're not getting deep into how to solve linear and how to solve quadratic equations. But it's important for you to know when to distinguish one another, right? Because actually quadratics and solving quadratics and graphing quadratics all interconnected. But, for example, if you have 2x, well, for that a special important detail. If I have y, right, equals 2x plus 2, right? What's the highest degree in this term? Degree in this term. We see it's 1, right? There's nothing is raised, the x, right? Our variable, to our variable. We can see that our variable is only raised to the first power, meaning this is a linear function. However, what if we have y equals x squared? This has a degree of 2. Meaning that it's not a linear anymore, but now it's a quadratic function. Right? So, let's get into how to graph these quadratics. So first things first, we need to know what the parent graph for a quadratic looks like. Parent graph is without any transformations is y equals x squared. So if we have our coordinate plane, let's do 1, 2, 3, 4, 5, and let's do -1, -2, -3, -4, and then let's do 1, 2, 3, -5, right? 4, 5, and then we can have 1, 2, 3, 4, 5. So it's the same concept, right? So what we need to keep in mind when graphing quadratics, the first things we need to know is the standard form, and the standard form is, well, there's different forms, right? We have the roots, which we're going to be talking about in the next video, and after in the next video we're going to be talking about the vertex form. But in this video we're going to be talking about the standard form, which is y equals ax squared plus bx plus c. In order to understand this, if we have a full quadratic equation in the form of y equals 2x squared plus 6x plus 4, if we want to find a, b, and c, we know that our 2 is in front of our square term, so we know that a is 2. Our linear term, the number in front of our linear term, 6, so we know that b is 6. And we know that our constant number without any variable is 4, meaning that c equals 4, right? We need to know how to distinguish these, right? So we have this. The first thing we need to do is to find our vertex, right? But in order to find a vertex, we need to have our line of symmetry. So some graphs, such as the absolute value graphs and our quadratic graphs, they're symmetrical. You can neglect one side to another, that they will be symmetrical, meaning that the y coordinate of the graph is equal. So in order to find this vertex, we need to find our line of symmetry. Which is in the formula of x equals opposite of b over 2a. We can see that x equals, right? If it's in the form of x equals, we know that's going to be a vertical line, right? And this is 2a times 2a. So what is our b in this case? Well, our b is 0. What is our a? We know that, right? You know, as we identified before, we know that our a here is 1. This is going to be 0, so our axis of symmetry is going to be here, right? We usually do a dashed line, but we know it's going to be in the axis plane. And then whatever our axis of symmetry is, we can plug it into our xy table to find the vertex, because our vertex is in the form of x over y. However, our x coordinate here is our axis of symmetry. So in order to find the y coordinate, we just plug the 0 into our function. 0 squared, 0, our vertex is here. And then we just find 2 points to the right or 2 points to the left, always trying to keep it close to the absolute, closest to absolute, in terms of absolute value as possible. So let's choose 2 to the right in this case, and then we just plug it into our function. So f of 1 equals 1 squared, which equals 1. And then there's a 2. We can say f of 2 is equal to 2 squared, which equals 4. So we do, so we plug in 1, 1, and then we have 2, 4. 2, 4. So that's going to be sort of like this. And then we just do our parabola. Remember, the parabola forms a U shape, right? It forms this U shape, or a negative U shape. I usually say a happy or a sad face. It depends on your A value, right? If your A is greater than 0, then you know that your parabola is going to open up. But if A is smaller than 0, you know that your parabola is going to open down. Right? So we already have this half here, but as I said, we have this line of symmetry here. So instead of actually plugging these 2 points, we can just neglect them. As I said, they're going to have the same, we said 1, so it's going to be, they're going to have the same y value. And then it's going to be, if this was 2, then it's going to be about here. Right? And then you have your parabola. Thank you all for watching the video.